Okay, in this video we are going to talk about more examples on curve tracing. Okay, the first thing we do here is this example, fx equals to y, x root under 2 minus x. Let's find out the y-intercept first. Okay, so to find out the y-intercept, do you remember what we do? We take x equals to 0, right? Let's find out the y-intercept. For y-intercept, set x equals to 0, right? So what you get is fx or y equals to 0, 2 minus 0, right? It is basically 0. So what is the point? 0, 0, because y is 0, x is 0 is the y-intercept. So to find out the x-intercept, what do? You set 0 for y, right? Y equals to 0. What you get is 0 equals to x root under 2 minus x, right? So what do you get? Either x is 0 because this equals 0, or 2 minus x equals to 0, root under 2 minus x equals to 0. So x equals to 0, and then from here if you square you will get x equals to 2. If you square you will get x minus 2 equals to 0, so x equals to 2. So what are the x and y intercept? So y-intercept x-intercept is basically when you set x equals 0 you will get y equals to 0, and it is 2 comma 0. Let us mark those 2 points. One point is right here, another point is 2, 0 here, maybe one is there somewhere. So next we need to find out the critical numbers. To find out the critical numbers, let's find out a y prime. So how do I find out y prime? It is like, you can think that as f, that as g, and then product rule, right? F prime is 1 times g is 2 minus x, and then plus x times g prime is this is basically 2 minus x to the 1/3, right? So 1/2. 2 minus x to the 1/2. So how do you find out the derivative? It is like u to the 1/2. 1/2 u, 1/2 minus 1, right? So that will be 1/2 u is 2 minus x times negative 1/2 times the derivative of u prime will be negative 1. So if you simplify this, what you get is root under 2 minus x and minus, because x times negative 1 is negative x, divide by, this goes to the denominator, so 2 root under 2 minus x. That's what you get. This is basically the f prime. If you want to further simplify, there is 1 in the denominator. You can do 2 root under 2 minus x, and just try the cross multiplication. It's like 2 times root that will be 2 times 2 minus x, and then minus x, right? Minus x. So basically what you get is y prime equals to, if you simplify this, 2 times 2 is 4, minus 2 times negative x, negative 2x minus x is negative 3x, divide by that denominator, right? 2 root under 2 minus x. So to find out the critical points, one thing you do is you solve the numerator and then solve the denominator. That's what you do, right? Meaning the critical point is the points, the values of x where y prime is 0 or y prime is undefined, meaning when the denominator is 0. So if the numerator is 0, you will get 4 minus 3x equals to 0, meaning 4 equals to 3x, right? So x is 4/3. That is one of the critical point. And then another critical point is x equals to 2, because when x, if you solve this, you'll get x equals 2. But what is the domain though? Domain is anything. See, if you take x equals to 2, you will get 0, but if you take x bigger than 2, then you will get negative number under the root. That means the domain is up to here only, right? X equals to 2 only. So the critical points are critical numbers are x equals to 4/3 and then x equals to 2. So now to find out the local max or local mean, what we do is you find out y double prime, right? And then what is y double prime? Actually I have found the y double prime value for this function. So y double prime, to find out the y double prime, what you do is you just do the quotient rule on here again. Okay, so you will get this, you will get 3x minus 8. After I use the quotient rule, I get this as the second derivative minus x to the 3/2. Now I want to check what is the value of y double prime at these critical points at x equals to 4/3, right? What is y double prime? Let's plug in 4/3 here. If you plug in 4/3, then 3 and 3 will cancel out. So 4 minus 8, you will get negative number on the top, and 2 minus 4/3, it is 4/3 is less than 2, so it will be positive. So it is negative, meaning f has local mean at x equals to 4/3, right? So meaning that there is somewhere 4/3 is 1.3 somewhere here, and x has minimum, meaning see the graph crosses x-axis at these 2 points. Now what it shows is at 4/3 it has a local max, okay, local max at x equals to 4/3. I don't want to check at x equals to 2. I mean, you can at x equals to 2. What do you get? Y double prime will be, if you plug in x equals 2 here, you will get infinity, right? Undefined. Basically this may be the point of inflection, undefined, but we are not interested on this because it is on the boundary, because this is the 2, right? So this is on boundary. Now we want to know what happens to the graph on the left side of 0, because on the right it is not defined, because this the domain is only bit left of 2. So negative infinity 2 is the domain, right? So we want to know what happens on the left of 0. So what we do for this is, let's write down draw a line and then plug the critical numbers. There is 4/3 here, 4/3, and then there is 2 here. So let's take a test point as 0. If you plug in 0 here, what do you get? I mean on the first derivative, right? Y prime equals to what is that? 4 minus 3x divided by 2 root under 2 minus x. Let's see the sign of y prime on the left of 4/3. I plugged in 0, I got 4 over 2 times 2 minus 0. 4 minus 0 is 4 over 2 times 2 minus 0 is just 2 root 2, so it is positive. On the left of 4/3 it is positive, meaning the graph is increasing. So meaning that it increases everywhere here, right? And at this point between 4/3 and 2, let's take 1.5, because 4/3 is 1.3. If I put 1.5, I will get 4 minus 3 times 1.5 is 4.5. So 4 minus 4.5 is negative 0.5. 2 minus 1.5 will be positive. So negative over positive will be negative on this side, right? Negative means decreasing function. So we see that it is decreasing on that side. So this is the graph basically. So let's do another example. Another example is we have y equals to 3 times x to the 2/3, that is the fractional power, right? And then minus 2x. So how to find out the intercept first? First let's find out y-intercept. To find out y-intercept, what you do is, as above as the previous example, you said x equals to 0. So you will get y equals to 0 minus 0, right? So 0. So basically you get 0, 0 is y-intercept. Let me plug in that 0, 0 here. 0, 0 is the y-intercept. Next thing is to find out the x-intercept. We said y equals to 0, right? Meaning you get 3x to the 2/3 minus 2x equals to 0, right? So how do you solve this is take x to the 2/3 out. If you take x to the 2/3 out, you will get 3 minus 2x over x to the 2/3, right? If you move this to the top, you will get x to the negative 2/3. So basically if you combine these two, what do you get? X to the 1 times x to the negative 2/3 will be x to the positive 1/3, right? Basically this will be 2x to the 1/3. And then there is equals to 0, right? So equals to 0. So if you solve this, what do you get? Basically what you are solving here is x to the 2/3 times 3 minus 2x to the 1/3 equals to 0. If you solve it, you will get either x equals to 0, because x to the 2/3 equals to 0, it means x equals to 0, or 3 minus 2 x to the 1/3 equals to 0, right? How do you solve this? You will get 3 equals to 2x to the 1/3 and 3/2 equals to, so x to the 1/3 cube on both sides will implies 27, so x equals to 27 over 8. So basically 3 point something, right? So one is x equals to 0, one x-intercept is x equals to 0, another x-intercept is 27 over 8. So 27 over 8 looks like this is 1, 2, 3 and 3 point, say 7 or 8, whatever. So it looks like the graph passed through this and these 2 points. These are the x-intercept and this is also the y-intercept. So graph will be either like that, or it will go from above like this. We don't know yet. Okay, so what is y prime? Let's find out the y prime. That's the next thing we will be doing here, because we want to find out the critical points, critical numbers. Y prime will be find out the derivative of y will be 3 times 2/3 x to the 2/3 minus 1 is negative 1/3 minus 2, right? And then if you simplify this, what you get is 2x to the negative 1/3 minus 2, right? So how do I find out the critical points? You set that equals to 0. That means 2x to the negative 1/3 equals to 2, right? Divide by 2. What do you get? You get x to the negative 1/3 equals to 1, right? Cube on both sides. What do you get? You will get x to the negative 1 equals to 1, right? So basically, how do I solve this? You move that to the bottom and then you will get 1 over x equals to 1. There is 1 in the denominator, so you flip that, so you will get x equals to 1. So the critical point is x equals to 1, right? X equals to 1 is the critical point. So how do I find out the local max and local mean? So what you do is you find out the second derivative. So y double prime. Y double prime is the derivative of this one, right? So you'll get 2 times negative 1/3 x to the negative 1/3 minus 1 will be negative 4/3. Just that one, right? Because the derivative of 2 will be 0. So if you simplify this, you will get negative 2 over 3 and then x to the positive 4/3. So this is the second derivative. So for the local max and local mean, you plug in the critical number into the second derivative at x equals to 1. Y double prime will be what? Negative 2 over 3 times 1 will be negative 2/3, right? Negative 2/3. That is negative. So the graph has the function f has local max at x equals to 1. So it looks like this. At x equals to 1, it has local max. It has like this, right? At x equals to 1, the local max. Now we want to know what happens to the left of 0 and the right of 0. We want to know that too. The one thing I forgot to tell you is, because what is y prime? Y prime is basically 2 over x to the 1/3 minus 2, right? At x equals to 0, y prime is infinity. So x equals to 0 is also the critical point, right? X equals to 0 is also the critical point. So when you find out the increasing and decreasing interval, you mark that 0 and then 1 and then take the test point here, and then test point here, right? So if you take the test point here, say negative 1, what do you get? If you plug in negative 1 there, so you'll get negative number, 2 over negative number and then minus negative. So it is basically negative, so it is decreasing. Let's plug in something between 0 and 1. Let's say 0.5 as a test point. If you plug in 0.5, you will get, let's see what you get. 2 over 0.5 to the 1/3 will be smaller than 1 number, right? A number is smaller than 1. 2 over number smaller than number will be smaller than 1 will be 2 divided by 0 point something will be bigger than 2. Minus 2, that will be positive. So it will be positive there. So it is increasing. And then the last one is, let's take a point, let's say 2 or 3, whatever you want to put. Let's plug in 2. If you take 2, then you will get, you can plug in either way. So 2 over 2 to the 1/3, it will be 2 over 1 point something minus 2, right? It will be negative. You can use calculator to find out that. That's why I draw this is negative. Left of 0, it is decreasing. between 0 and 1 it is increasing, and then it starts to decrease. So graph is not perfect here, but this is how what the graph looks like. Okay, all right guys, thank you.